basically our project was the glove-operated digitally synced hand, or God's hand for short. The premise of our project was for hazardous environments such as Fukushima or like bomb disposal, where you don't want any human life to come in contact with these things, but you still need like the nimble dexterity of a human hand. So basically what we've done is we've modeled all of our parts using Pro-E and then used a 3D printer to print out the actual hand. The form is actually just made out of aluminum that was bent and then later powder coated.
The way the system recognizes your hand movements is there's flex sensors running down the back of the glove. They work very similarly to strain gauges where they change in resistance depending on how much they're bent.
So they're communicating using XB wireless communicators, which are two-way. And because they're two-way, we are able to do closed-loop feedback control.
While it's still holding?
That's the most important one.
Why don't you show each one? Why don't you show each one except the middle one?
Our problem right now, the reason they're not staying open is we've got these little tensile rubber bands that people use for their braces on the back of them, and they just wear out really quickly. They're not very strong, so that's what's holding the hand open.
So we use two different microcontrollers for this project. There's an Arduino in this control box, which is taking the input as analog and then transmitting it to our PIC16 F88. And then that converts it to pulse width modulation to servo motors. The servo motors turn, pulling on fishing wire, which runs through the back of the palm and then through the inside of the fingers. So by tightening the cords, we're able to open and close the hand. So in here we have our wireless XB, which is transmitting to the one on the PIC underneath here. This is the Arduino microcontroller. Our flex sensing input is coming through here as voltage divider circuits because they are similar to strain gauges. This is our custom audio amplifier circuit we designed, and these are our control potentiometers and our input and output.
That's selectable on the actual control pack here. And
Originally it's supposed to be a cutting laser, but due to power constraints, obviously we can't do that. So right now, again, this is more of like a prototype, but like in an actual circumstance, you send it into somewhere, it needs to cut through something, here you go, it actually has a cutting laser on it.